Good afternoon, Prof and fellow classmates. We're Group 19 and we'll be presenting on the future of driving, autonomous vehicles. Autonomous vehicles, once a concept from science fiction, on the cusp of becoming reality with advancements in technology. In this presentation, we will explore the mechanisms behind AVs, the benefits and challenges faced in integrating them into society, and provide our analysis on the major players in today's AV market. To kickstart the presentation, let us first learn more about AVs. As you can see in the diagram here, the Society of Automotive Engineers defined 6 different levels of driving automation, ranging from level 0 with no driver assistance system to level 5 for fully autonomous driving. For the purpose of this presentation, we will define an AV as a level 5 vehicle that uses an automated driving system that can sense external conditions and respond to them without human involvement. So you must be wondering, how exactly does an AV work? For a vehicle to drive autonomously, it relies on various internal and external sensors to monitor its surroundings, detect oncoming obstacles, and plan its route safely. Sensors such as cameras, radar, and LiDAR are used to collect input data such as information about traffic conditions around the vehicle, the distance and speed of objects concerning the vehicle in real time, 3D images of detected objects, and 360-degree maps of the vehicle's surrounding. After collecting vast amounts of data from the sophisticated sensory system, artificial intelligence is applied at different levels in the self-driving mechanism, including perception, localization, prediction, and decision-making. I will now pass on the time to Ming-Hing, who will further elaborate on the various parts of the self-driving mechanism.
Thank you, Kylie. Firstly, perception allows the vehicle to identify the state of surrounding objects, such as pedestrians or other vehicles. It uses a convolutional neural network for image classification on each frame of information received by the sensors mentioned by Kylie. As the classic CNN is unable to identify multiple objects in a single frame, image localization techniques such as a sweeping window or region-based CNN is used to identify multiple objects in real time, as seen from the video on the right. Next, visual odometry is used to localize the vehicle to its surrounding. It uses key points in consecutive frames to compute the relative position and orientation of surrounding objects in order to estimate their 3D position. A recurrent neural network is then used to anticipate the behavior of these objects. The neural network uses contextual information from the features extracted in CNN above, such as how a given object is moving relative to its static surroundings, in order to generate predictions of its future position and velocity. So at this stage, a 3D model of the surrounding is generated with high precision, as seen from the video on the right. Lastly, deep reinforcement learning is used to train the decision-making algorithm of the vehicle to make optimal decisions. The unsupervised neural network learns by exploring a simulated environment, as real-world consequences can be very costly. The algorithm is trained to maximize cumulative rewards, even for each action that it takes. So these rewards can be positive or negative, depending on factors such as passenger safety and traffic regulations. Now I'll pass on my time to Chuen, who will talk more about the potential benefits that autonomous vehicles can provide.
Thanks, Ming-Hing. So firstly, the most direct benefits of AVs is increased road safety. According to a study by Stanford, 90% of motor vehicle crashes are caused, at least in part, by human errors. AVs can be more alert, responsive, and law-abiding than human drivers, and it is possible to reduce vehicle fatalities caused by human impairments, improving road safety and reducing accident costs. Secondly, AVs provide social equity and inclusivity. Shared driverless vehicles provide an affordable way of accessing self-driving technology. This will enable more individuals to travel on their own, such as people without a driving license or those with disabilities. More people can now enjoy the convenience of having a car on demand. Next, AVs can be more efficient and optimized compared to human drivers. With vehicle-to-vehicle communication, AVs may exchange information about their current positions, routes, and road hazards that they see. AVs can use this information to optimize their routes and minimize delays for all users in the system, saving time for their passengers. AVs can help with the ride-sharing economy as well. Self-driving cars remove the largest expense, human drivers, for ride-sharing companies like Grab and Uber, and private owners of AVs may have the option of renting out their vehicles when idle. These increase the pool of ride-sharing vehicles on the roads, providing cheaper transport alternatives and reducing the need for private vehicles overall. Lastly, there are good implications for city planning. According to a report by Accenture, people are more willing to relocate further from the city center if offered autonomous mobility solutions. Houses in rural areas are more affordable, and it will ease pressures of urban overcrowding in the city if people move further away. The reduction in vehicles allows for excess parking spaces to be repurposed into housing and recreational spaces. Now, Mingzhi will go into the challenges posed by AVs.
Thank you, Chuen. Firstly, the inadequate legal framework for countries poses a challenge, especially regarding liability during an accident, given that there is a lack of human control. Does the driver become an innocent bystander or still bear some form of liability? We need to find a balance between the responsibility of AV owners and AV manufacturers. One current mitigating solution is to ensure all owners of AVs purchase motor insurance such that any accidents can be covered. Next, we have the ethical dilemma that comes with AVs. The main ethical conflict is between the interests of the passenger and those of the community, such as innocent bystanders or pedestrians. One popular approach that attempts to resolve this is utilitarianism, which seeks to save the greatest number of people. However, this is overly simplistic and does not take into account any other factors. Another approach developers have considered is the Gaussian algorithm, where the self-driving software will estimate the probability of survival of each person that's involved in the crash. It will then try and minimize the harm for whoever is worse off in the accident. However, the challenge lies in whether the current technology is advanced enough to sense and precisely come up with the probability of survival. The next challenge is that an AV is fully controlled by computer hardware and software, hence it will be susceptible to hackers. A malicious attacker could possibly exploit security loopholes to take over a car and possibly force it to crash. Hackers could also attempt to steal private and financial data from the AV or the companies that store this information. Last but not least, public's receptiveness towards AVs is still unknown, given that this is novel and there's a lack of proven record in terms of safety. It will take time for the public to adapt to the new technology and feel comfortable enough to use AVs on a regular basis. AVs will also result in various groups of people, such as full-time drivers or truckers, being concerned. They may be apprehensive about the safety of driving on the same road as AVs. Furthermore, their jobs may also eventually be replaced by these self-driving vehicles. That is all for the challenges, and I'll now pass on the time to Daniel.
Thanks, Mingzhi. So now let's have a global perspective on things. More specifically, let's take a look at both the US and China. So while generally industry leaders agree that the US exceeds China in terms of policy and legislation, technology and innovation, infrastructure, and consumer acceptance, China, in terms of sheer volume, has already surpassed the US to become the world's largest AV market. And with Chinese support, they are likely to become the world's largest market for AVs in the future. But of course, all of this does come at a cost, because the explosive growth in automotive-related infrastructure has resulted in much more congestion and pollution in Chinese cities. So to really determine which country will win the AV race, let's take a look at some of the companies coming out from these countries. For the US, we have Waymo, which is a subsidiary founded by Google in 2009, and they currently run a fleet of 600 robotaxis in Phoenix, Arizona. By extending this to San Francisco, known globally for their treacherous road conditions, they hope that this will be sufficient enough to roll globally. For Cruise, more specifically, their Cruise Origin is a vehicle without any steering wheels, mirrors, or pedals, essentially no driver input whatsoever, leaving passengers to just sit inside. They also recently inked a deal with Dubai to become their exclusive driverless robo-taxi provider. And we're going to mention Tesla as well, because while they're currently still level 2 in terms of automation, because of the way that they roll out updates through the cloud, it is possible for every Tesla customer to receive a level 5 driverless vehicle without having to upgrade their hardware. And as for China, we have Pony.ai leading the way, which is the first mover in terms of both consumer and logistic transport. And they have partnered with Toyota-S-AM in the Pony Pilot Plus fleet. For Baidu Apollo, their main crux is in their open source driverless operating platform, the Apollo 3.0. Their car batteries are both reputable and maintained well, and they launched a self-driving taxi service in 10 cities across China. By looking at some of the startups, we have WeRide.ai, which is the first startup to hold driverless test permits in both China and the US, and they also rolled out a fully driverless robo-bus service in Guangzhou. Next, I'll pass on the time to Vicky, who will run us through our evaluation and conclusion.
To compare the 6 companies, we created a metric consisting of 5 criteria. First, valuation of the company. Second, cost of the company's product. Third, drivers' disengagement. Fourth, fit principles, which includes fairness, ethics, accountability, and transparency. And lastly, partnerships or collaborations that the company has with other companies. Each criterion is ranked on a 5-point system, where 1 equals the best and 5 equals the worst, and the total points are computed to compare the 6 companies. The definition of the points for each criterion is as shown on the slide. Using the metric, for US companies, we computed that Waymo has a total score of 8, Cruise has a total of 13, and Tesla has a total of 16 points. For Chinese companies, Pony AI has a total score of 14, Baidu Apollo has a total of 10, and WeRide has a total score of 15 points. Based on our evaluation, we see Waymo as the current leader in the AVs market, and the US companies seem to have higher company value and lower product costs than the Chinese companies. However, given the rapid rise of innovation in China, it will be unsurprising if Chinese companies overtake US companies in the near future. In conclusion, the innovation and potential of AVs are bright and limitless, where there will be increased transportation safety, more ride-sharing and efficiency, city planning that reduces pressures of urban overcrowding, and increased social equity and inclusivity. However, to unleash the potential of AVs, companies need to first resolve the ethical dilemmas, encourage the public to be more receptive towards AVs, and solve the current regulatory and technological constraints. Once successful, AV companies will be able to increase the mobility options for the world while reducing the number of vehicles on the road, thereby lowering traffic congestion and pollution. However, these AV companies need to lead and serve the AVs market with a good heart, use technology with creativity, and possess compassion for the community to be sustainable. With that, we have come to the end of our presentation. Thank you.